All right, everybody. Like you said, my name is Alex Thomas. I'm a grad student working with drones in the Food, Ag, and Biological Engineering department at OSU. Uh, and I've mostly focused on seeding with drones. Uh, all right, so like we saw, we got the imagery drones with the sensors and the cameras used for crop health monitoring and ag. But now we've got these drones over here. We can use them for pesticide applications, nutrient applications, cover crop interseeding, uh, just with a switch of a tank. It's pretty fast. You just unplug it, take the tank off, put the new tank on, and hook up some hoses, and you can be switching operations pretty quick. So just on the left, you see it spraying. Then over here on the right, you got one spreading. Uh, on the hardware side, imagery drones, you got the camera, sensor, controller, software. It's pretty much all the same, except the application. You're gonna have the material tank, your pumps for your liquids. Most of these drones right now are coming out with the rotary atomizing nozzles, so you can change the droplet size on the controller. And the US-based company, right now you can put your traditional nozzles on those. The granular tank, you got the material tank, the metering system. Right now there's two different metering systems coming out on these drones. There's a hopper gate system and then a dual auger system for the metering. And then the spreading system, you got drones with the single spinner disc spreader on the bottom, or you got the XAGs that have a two vertical discs that create a flat fan pattern with that product you're spreading. These drones come with an onboard scale most of the time, so it makes calibration pretty simple. It's just software. You press calibrate with your material, and it goes through a process of dropping it and using the onboard scales for that calibration. So we started doing some frost seeding pastures, Eastern and Jackson research stations. And you see there's snow on the ground. We want to spread the seed over it and let the freeze thaw cycle help incorporate some of that seed. So we spread that in early March last year. And as one of the benefits was shown earlier, one day we were able to fly the drone and we had to wait a couple days for the ground to dry up to be able to get the ATV out there to spread that for the comparison. So we did two different mixes. We did a grass seed mix and a clover seed mix. So these DJIs, they have two different hopper gate sizes. So for the grass seed, because it's a little bit larger seed, we used the large hopper gate. You see we were shooting for a 6 pound an acre rate. We averaged 6 pounds an acre. We had a little bit of variability compared to the clover seed. The clover seed is a smaller seed, as you probably know. So we used the small hopper gate system, and we had pretty close average to our target rate. The big thing is watching at those low rates. Some of these the control modules for the hopper gate system are going to have its limitations. So if you do really low rates, it's not going to open up enough for you to have a consistent flow through each of those holes on the hopper gate. So you probably need to check that before you fly to make sure you're actually spreading. So this year we did a little bit more pasture spreading. Last year we spread over some pretty grassy areas, so we weren't able to really look at emergence very well. So you can see we have some really damaged areas from cattle, where they were feeding at over the winter. We did the same mixes, and we're going to be using forage samples to compare. So one thing to note, these drones, they do have terrain following, but there are its limitations. Over in Eastern and Jackson research stations, you got some pretty steep hills, ditches, and everything else. So while these drones, they can have their autonomous operations, once you map the field, you might have to help control that altitude so it doesn't stop and start, and kind of helps with that. And then again, I just mentioned, you got to double check that hopper gate opening at the low seeding rates. All right, so we've also been doing some testing on the actual settings of the drones, and you can find some of these in the eFields. I put the eFields pages if you want to go read more about it. So we tested at different spinner disc speeds, just to see how it would affect the spreading patterns. So we tested at 550, 800, 1050, and 1300 RPMs. Flew it over the Cinepans. So we did this testing with cereal rye at 60 pounds an acre. We do a 15 feet altitude when we're spreading. That just gives the seed enough time to spread as wide as we can get it. And we flew it at the max flight speed of 32 feet per second. So this was just the single pass results. So you can see there's a leftward skewness on all these, and that was what we thought would happen because a single disc spreader, whether it's on a ground rig or anything, has that a skewness to one side or the other, but on the drone, we see it to the left. So as we increased our spinner disc speed, we decreased our skewness. So you'd really probably 550 is too low anyways to be running at, but we just wanted to show that by increasing your spinner disc speed, you can reduce your skewness. As far as spreading width, when you spread serial ride, we didn't see any difference in the spreading width when you spread the 1050 or 1300 RPM. So this, we use this graph to try to determine what you should set your route spacing to have uniform application. So here we're shooting for below a 20% variation. So the 550 RPM, you can see again, at this. So you get your variation pretty high at like a 10-foot route spacing. And while the 800 RPM, you can get a route spacing up to about 26 feet. Your average rate, if you don't change your application rate, it's going to change. One thing to note is when you change your application rate, it's going to change your hopper gate opening percentage. And that's going to change your drop point on the spinner disc. So all of these settings are going to, affect what your spread is going to look like. So you probably need to test under those settings to make sure you're going to get your target rate and uniform application. So we did some more testing. We know people planting cover crops, they're planting single seeds, and we're starting to increase, the number of mixes that are being used. So we did some mixes with cereal rye, and so mix A, we mixed cereal rye with crimson clover, and mix B, we mixed cereal rye with radish. And with those mixes, we did our spread. We separated the two seeds out, and then looked at what the distribution pattern would look like to see if it would affect it. So here you can see on the cereal rye, it kind of peaks a little bit higher to the left. See that left skewness. When we mix it with the radish seed, it helped kind of flatten out some of those lines so you don't have as many dips in the patterns, but you still kind of see that. So here with the crimson clover, it stayed pretty much the same. Your skewness, you kind of have a lower dip in the middle, but you don't really have a high skewness. The peak is the same on both sides of the flight path. Compared to when you spread it single, you still just see that left skewness. So this result with the radish seed is we were trying to spread at a 5 pound an acre rate using the large hopper gate. And that kind of shows why you need to use a small hopper gate, because your metering is going to be off. You're going to have really high variation across the swath. So you just need to make sure you're using the right hopper gate. So here, this is just a table of that graph I showed you for the uniform application at different route spacings. So here we have the cereal rye when it was spread by itself, when it's mixed with crimson clover and radish. We won't really look at the radish data because of those skewed results, but the big thing here is when we mixed cereal rye with crimson clover, you can see the crimson clover, you can get up to 39 feet with less than 20% variation, but your cereal rye is going to be at 16 feet. So you probably need to limit it by the limiting seed to make sure both seeds are being spread uniformly. All right, so one application that these drones are really being used for is to start implementing cover crops earlier. Before harvest, you're not having to wait until you harvest to drill the seed in. You can go ahead and get that biomass growth before we get frost. So we went out and put these pans into corn and soybean fields. That was being spread by a custom applicator over in Darke County. We had 2 T30s flying. So across the field, we saw about 23% variation in the rate. And in the soybean fields, we had a little bit lower than target rate. So we're shooting for less than 20% variation. So that it gets close. It's not as good as a ground rig yet, but you can adjust some of your settings to try to reduce that variation. as we showed with the spinner disc speed. And there's those two drones. They were being swarmed in the same field. We did this again. We put some pans out for, this year he was flying with the XAG P100 Pros. That's going to be the one with the two vertical spinning discs. So with this drone, now he was flying at 2 passes over the field, and he was doing one in one direction and one in the other at half rate to try to reduce his variation. But across the field, we saw variation in from 17 up to 50%, and that's really not what we want to see. I think we did this on 8 fields. 2 of the fields were less than 20%. Most of them were in the 30% range, but we saw a max of 50. And that could just be he needs to do more pattern tests to kind of dial in his settings. So he's reducing that variation across the field. But we also, in this testing, we put some pans in a row to just see what it looked like across the swath. And I mean, the variation looked okay, but across field didn't look good. And then there's that drone spreading again. So some testing that I flew, we flew into different canopy stages to try to see how the canopy would affect your deposition of seed onto the ground. So we tested it in green canopy, 50% dry down and harvest ready on corn, soybeans planted on 30-inch rows, and beans planted on 15-inch rows. And we were doing zero ride at 60-pound acre rate. So this table's kind of got a lot going on. Kind of the big thing I want to show is those 2 orange lines. That's the 15-inch and the 30-inch beans, the average rate across the swath. So you see that's higher than the rest of them. So when you're spreading into the green soybean canopy, that is so dense, it's just funneling that seed to the middle of the rows. So you might see some streaking and growth as it starts to emerge. And in that, you can also see there's still some slight skewing. Just one other thing to note. So that big difference in the soybean was the only real difference we saw in those applications. That's what the table's showing. All the corn applications, the average rate remained the same in the middle of the rows. And then we saw some difference in the soybean, the harvest ready applications, but we think that was an issue with the pans we were using. One thing to think about when you're applying, so when you're aerial seeding, most USDA requirements are going to tell you to increase your rate by 20% to make up for poor emergence, just because you're not incorporating that seed. But you might see some loss just by canopy interception. So in some of the corn collars, we were seeing up to 4 to 5 seeds. And it really comes into, in those pans we were putting out, at a 60-pound acre rate, we should expect probably about 60 seeds. But when you see that many seeds, getting caught in the collar of one collar, and then some getting caught in leaves, it can probably throw off your numbers. In soybeans, we didn't really see much interception. The big thing was when you're spreading early in the morning, there was still dew on the leaves. But that seed will eventually make its way to the ground. So some things to take away from this. Spread pattern testing should be done to make sure you're having a uniform application and meeting your target rate. For the single disc drone spreader, you're going to have to make adjustments to those settings to reduce your skewness. When you're interseeding into soybean before defoliation, you can expect that funneling factor. So you should probably wait until it starts to defoliate so you don't have so much funneling of the seed. And one big thing when you're interseeding, you need to make sure you're spreading in right conditions. The soil moisture has to be right, whether that's you spread right before rain or right after rain, which is kind of another door drones open up. You can't really get out into the field right after a rain with a ground machine. And we wanted to pull some emergence data and biomass growth, but because of drought conditions, the emergence wasn't great. So yeah, that's all I got. And y'all have any questions, let me know. There's mine and Dr. Fulton's email if y'all have any other questions too.